Good morning, all of you. Now we are learning unit number 2, P block elements 1. Today our topic is to learn about allotropes of carbon. Already we learned that carbon exists in many allotropic form. There is a most common allotropes of carbon are graphite and diamond. And other important allotropes are known. That is first one, fullerenes. Second one, carbon nanotubes. Third one, graphene. So each one have different shape, different structure. Let us we can discuss one by one. Today we can be discuss allotropes of carbon. What is about the allotropes of carbon? Some element have same physical state, but they have different forms. That means more than one form, or two form, or three form, or five forms, like that. Some of the element have exist different forms. For example, carbon exists in many different allotropic forms. But the small class we learn about that. Diamond and graphite are the most common allotropes. But we have remaining some of the allotropes are having. About that, one is graphene, fullerenes, and carbon nanotubes. These are all newly synthesized forms. Okay. What about the graphite? Graphite is the most stable allotropic form of carbon at normal temperature and pressure. Can you understand, my dear children? It is only at the normal temperature and pressure. Graphite is the most stable allotropic form. Okay? Allotropic form of carbon. It is a soft, graphite is a soft, and it conducts electricity. Why it is a soft means they are held by van der Waals force, that is weak van der Waals force. They have one weak bonds. They conduct electricity. What is the reason here? We know that the atomic number of carbon is 6, am I right? First shell, we can be accommodate 2 electrons. Second shell, we can be accommodate 4 electrons. This out of the 4 electrons, here each carbon atoms forms 3 sigma bonds. Okay. That is with the neighboring carbon atoms, the nearest carbon atoms. So, out of 4 valence electron, 3 electrons are utilized for the bond formation. So, there have 1 free electrons. These free electrons are not bonding to the nearest carbon. This free electron can move, am I right? Due to the movement of these electrons, it can be conduct electricity. We can discuss that, am I right? Here, graphite is a soft. What's the reason? The carbon atoms are held by van der Waals force.
And one more important point, it is composed of flat two-dimensional sheet of carbon atom. Flat two-dimensional sheet. We can discuss the diagram. Here, having a number of sheet, when we are looking the diagram, try to look the diagram. Each sheet is a hexagonal net of sp2 hybridized carbon atom. Here we are explaining about the sp2 hybridized carbon atom. We know that what is about the hybridization. Already we discussed hybridization. It is a concept of intermixing of an orbital. Am I right? We get one of the hybrid orbital. Anyhow, carbon exists in the graphite. It has a sp2 hybridized carbon atom. Why sp2 hybridized means? Carbon is surrounded by one of the small trick I am saying how to write the hybridization. If one of the carbon atom is surrounded by 4 different carbon atom, that type of the bond we are saying sigma bond. Am I right? Suppose the carbon atom is surrounded by 4 different atoms. 4 different carbon atom means carbon having 4 bond. Am I right? This we are saying sp3 hybridization. Because having sigma bond, we are saying sigma bond. That's only one single bond. Am I right? Here one single bond, single bond, single bond, single bond. Suppose carbon exists like that. See, another one carbon atom, another one carbon atom, another one carbon atom. So here having this carbon is surrounded by 3 other carbon atom. But the bond is, here having only 3 bond. Am I right? 1, 2, 3. Carbon have tetravalent bond. Am I right? So make it one here. So one double bond. If suppose here double bond comes means it is an sp2 hybridization. Single bond means sp3 hybridization. Can you understand? Double bonds here means each one carbon atom is surrounded by 3 different carbon atom. One carbon atom is surrounded by 3 different atoms. So there is a must of one double bond. Am I right? So here this carbon have sp2 hybridization. Suppose a single bond having means we are saying sp3 hybridization. Here graphite, carbon, the carbon atom, the central carbon atom possesses an sp2 hybridization. So we are explaining about that. What is the bond length of carbon-carbon atom? What is the bond length? Here, bond length is 1.41 Armstrong unit. Am I right? This 1.14 Armstrong is very close to benzene molecule. Benzene molecule, carbon-carbon atom. We know the structure of benzene. Am I right? How you draw the structure of benzene? This is the structure of benzene. Yes or no? So each corner having carbon, 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 carbon like that. Am I right? 6 carbon. So this carbon-carbon bond distance in benzene is about 1.40 Armstrong unit. Am I right? But in our graphite, carbon-carbon bond length is 1.41. So we can be say carbon-carbon bond length in graphite is 1.41 Armstrong, which is very, very near close to carbon-carbon bond distance in benzene. What is the theoretical value that one? 1.4 Armstrong. Here, why the graphite is conducting electricity? That's one of the important point. Why graphite? We know our pencil tip also having graphite. Am I right? It's also made up of carbon. Graphite, we are saying. It is easily conduct electricity. Am I right? Why? What's the reason? Each carbon atom, that means I told that carbon having outermost shell having 4 electrons. These 4 electrons can bond to other 4 carbon atom. Am I right? So one carbon atom is surrounded by 4 other different carbon atom. Each carbon atom forms 3 different carbon atoms. So I am drawing the structure like that. Carbon, 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 carbon. So one of the carbon atom, the central carbon atom is surrounded by 3 different carbon atoms. So I am making the bond, one single bond, single bond, single bond. Then valence is 4. We know that. Again I am making here. Here on side double bond. So I told that if the carbon is surrounded by, one of the carbon atom is surrounded by 4 different bond, am I right? That is a single bond, 4 bond, single bond. We are saying sigma bond, am I right? That means sp3 hybridization. Here having one double bond, so it must be an sp2 hybridization. Anyhow, each carbon atom forms 3 sigma bond with the neighboring carbon atoms, that is the nearest to carbon atoms, using 3 of its valence electron. We know carbon having 4 valence electron. So out of 4, 3 is utilized for sigma bonding. Am I right? For bonding. The 4th one is present. Am I right? 4th electron is present. It is an unhybridized p orbitals form pi bonding. Unhybridized. Listen all of you. Before that we have to write the electronic configuration of carbon. Electronic configuration, the atomic number of carbon is equal to 6. Electronic configuration already we learned it. 1s2, 2s2, 2p2. Am I right? This is in a ground state. Am I right? Ground state. 1s, 2 electron, 2s, 2 electron, 2p, 2p also, 2 electron. We can be accommodate singly. Am I right? That is 2px, 1 electron, 2py, 1 electron, 2pz, having no electron. Am I right? So what about the excited state? Excited state, 1s is stable. We cannot be take the electron. Am I right? This is stable. About the 2s, next you have to draw 2p, 2px, 2py, 2pz. Am I right? So from the ground state, listen all of you. From the 2s electron, one of the electron goes to where? In the 2pz subshell. Am I right? It is jump from here to 2s to 2p. Okay. So because there is a vacancy, so one of the electron goes there. So here, this 2s and 2p subshell combines to form sp2 hybridization. That means the electrons are pairing takes place, and 2s and 2p. 2 electrons are having 3 electrons. One of the other carbon atom coming here and pairing. Due to the pairing of 2s having 1 sigma bond, and 2px and another one 2px having 1 sigma bond, and another 2py and another 2py also forming a sigma bond. So here we get a sigma bond. Here the 4th one having unhybridized p orbitals. Here this unhybridized p orbitals undergo overlapping with another one unhybridized p orbital to form a pi bond. Which bond? Pi bond. These pi electrons are delocalized over the entire sheet. We know that the flat shape, am I right? Already we learned that the flat shape of two-dimensional sheet of graphite. Here, the pi electrons are delocalized over the entire sheet. What's the meaning of delocalized? One electrons are unhybridized, am I right? These unhybridized electrons moving, delocalized means moving the electrons in the entire sheet, the entire graphite sheet. Due to the moving of these electrons, it is responsible for conductivity, electrical conductivity. Okay. Next we can draw about the diagram of graphite. Just we are attending, okay. We can attend the diagram for the examination point of view, okay. Just to attend the diagram. Just like you have to take on a small cyclohexane like that, cyclohexane, okay. Just a small, okay. We are trying one of the benzene without the bond, okay, a single bond. All of them are single bond, okay. So first you try like that. Joining here and one more join here, joining, here also you can be joined, here also you can be joined, okay, clear. This is a first set of layer, okay, first layer, we can be see the first layer. You have to draw the second layer and also third layer, okay. This is about the second layer. Next about the third layer, okay. Okay, third layer. Just to, we are making a weak bond, van der Waals force, am I right? Van der Waals force, weak van der Waals force between these layers. You have to mention like that. These are the weaker bond. Okay, these are the weaker bonds. That is weak van der Waals force. Here, this is the strong bond. Okay, this carbon and this carbon having strong bond. Okay, that's we are saying covalent bond. Am I right? Then mention the picometer. Okay, the distance, carbon distance we are giving 142 picometer. Am I right? Next here, this distance 355 picometer. Okay, this is how to mention. This is about the structure of graphite. Next, we can be discuss about diamond. What is about the diamond? Here, as we are comparing diamond to graphite, diamond is a very hard element, very hard element. The 10th grade we learn about the diamond, am I right? It is most of the diamonds they are using for jewelers, am I right? Here, the carbon atom in diamond is sp3 hybridized. See, what is the reason sp3 hybridized? Already we learned about the sp2 hybridized. sp2 hybridized means it must contain one double bond. Am I right? What about the diamond here? sp3 hybridized means each carbon atom is bonded to other 4 different carbon atoms. So it must having single bond. Am I right? Sigma bond, single bond. Am I right? Yes or no? So the carbon atom is, one of the carbon atom is surrounded by 4 different carbon atoms. And these carbon atoms are bonded to 4 neighboring carbon atoms. By which bond? Sigma bond. Here about that carbon-carbon bond length is about 1.54 angstrom. So this molecule shows a tetrahedral arrangement. What is about the tetrahedral arrangement? Carbon, 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 carbon. This is about the tetrahedral arrangement. Here, this one of the central carbon atom is surrounded by 4 different carbon atoms. Here all electrons, all 4 electrons, that means 4 valence electrons of carbon atom involved in bonding. Am I right? These are all bonding with other carbon atom. This bond other carbon atom. There is no free electron for moving. Am I right? There is no free electron here in the diamond. So, diamond cannot conduct electricity. Am I right? He having no free electron. Graphite having one free electron, so it will be conduct the electricity. But in the case of diamond, all electrons are bonding. So there is no free electron for conductivity. Okay? So it is a reason diamond is the hardest element. Okay? So it is make, due to the hard, it is make for cutting tools, cutting glass, making bores, rocks, drilling, etc. They are using like that. Okay? Then here also we have one diagram like that. Okay? A structure of diamond. We cannot try as usual. Okay? The carbon, second one carbon, here, carbon, 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 carbon. Okay. Next I am starting here. Carbon, 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 carbon. Okay. Next I am starting here. Carbon, 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 carbon. Okay. Next again I am starting here. Carbon, 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 carbon. Am I right? Next I am starting here. Like that we can be increase the ring. Okay. This is the actual form. Okay. You have to try like that. Okay. This is enough for the examination. Okay. Like one of the ring we are making 6-membered ring. Am I about that the other 3 remaining forms, which are the other 3 remaining forms, means fullerenes, carbon nanotubes, and also graphene. These 3 are the recently discovered allotropic form. What is about the first one? Fullerenes. It is a newly synthesized allotropic of carbon. It is prepared by the evaporation of graphite using a powerful laser light. Okay, this is the discovery. There is no need, just only for the understanding. Here, this fullerenes form is one of the discrete form, one of the big form. Am I right? Such as like that carbon 32, carbon 50, carbon 60, carbon 70, and carbon 76. Like that, they are increasing the molecules. These molecules have a cage-like structure. Cage-like. Cage means all of you know that one, am I right? cage-like structure. Carbon 60 molecules have a hollow saucer ball-like structure that we are saying Buckminster fullerenes, or we are saying buckyballs. We are saying just like one of the football like that. Am I right? Buckminster fullerenes means is one of the great scientists, one of the inventor, okay, and also one of the designer. Okay, there's about the he was give one of the structure like that. Okay, so they named us his name. And also, one of the important point in our subject, our topic, what is about the fullerens? That means it has a fused ring structure. Which structure? It has a fused ring structure. It consists of 26 membered ring. How much membered ring? How much is 6-membered ring? 26-membered ring. 6-member. Okay. And also 5-membered ring. How much 5-membered ring? 12 5-membered ring. What is about the 6-membered ring and 5-membered ring? 6-membered ring means this is a 6-membered ring. Am I right? 6-membered ring. This is a 6-membered ring. How much you having? 20. 5-membered ring. That means like that. This is the 5-membered ring. How much you having? 12. This is the important point. Each carbon atom is sp2 hybridized and forms 3 sigma bond, just like graphite. Am I right? And they have a delocalized pi bonding, give the aromatic character of this molecule. One of the aromatic character, one of the hydrocarbon. Am I right? Aromatic. The bond distance, what is about the bond distance? 1.44 Armstrong, and that is about the carbon-carbon single bond. What about the carbon-carbon double bond? That means try to draw the structure. First to make it one 5-membered ring. This 5-membered ring, first to make it a 5-membered ring. Then after this one, how to make it like a 6-membered ring. Okay, one of the 6-membered ring. Try to, okay, 6-membered ring. Next you join here. Next to make it a small circle like that. Okay, small circle like that. Okay, just like this is enough for the structure. Okay, carbon nanotubes. This carbon nanotubes also recently discovered allotropic. Here starting having graphite like tubes with fullerens ends. That's important point. These nanotubes are stronger than steel. Very, very stronger. Okay, as we know about the steel, what is the strength of steel? All of you know that one. Stronger than steel. It is easily conduct electricity. About the carbon nanotubes, you have many applications in nanoscale electronics, catalysts, polymers, and also medicine. Here, why we are saying carbon nanotube means it have one of the cylindrical like structure, hexagonal shape. Am I right? Hexagonal, like that, hexagonal shape. It we can be measured only in nanometer. this type of the allotropes are measured in nanometer. So we are saying carbon nanotubes, okay? So try to draw the structure, a simple structure, just to have to write hexagonal layers, a small like that, okay? Try to draw that one, a small hexagonal shape, okay? Other form of one of the carbon is about the graphene. It has a single planar sheet of sp2 hybridized. sp2 hybridized. Here, the carbon atoms, they are densely packed in the honeycomb. You know about the honeycomb, am I right? That like shape, okay, in the crystal lattice. Just also that also we can be easily draw the structure, okay. My dear children, it's very important. I am not expecting the diagram. Try to learn this question. Very important. This for 5 are important. So try to learn this one. So anyhow, today assignment I am giving only for the graphite. Okay, only for the graphite. So you have to write carbon is the most stable allotropic form of carbon at normal temperature and pressure. It is a soft and conduct electricity. It is composed of flat two-dimensional sheet, and it has the sp2 hybridized carbon atom. Don't forget to write the bond length. Carbon-carbon bond length is 1.41 Armstrong unit, which is close to carbon-carbon distance in benzene, about 1.40 Armstrong. Here having 4 valence electron. Out of the 4 valence electron, 3 of them are utilized for the bonding with the neighbor atoms. The 4th one is utilized for the electrical conductivity. The successive carbon sheets are together by van der Waals force. Am I right? Then, what is the applications? I forgot to tell the applications. It is used in the lubricant, either on its own or its graphited oil. Okay, that's also, please learn it. So, okay, thank you all of you. Thank you. Please write this question for the assignment. Okay, thank you all of you. Thank you. Have a nice day.